Hi Jakarta, my name is John Peterson and I'm a graduate student at Rice University. I am in an environmental statistics class right now with 11 other engineering, statistics, and science students. Our professor, Dr. Lauren Ron, works closely with the local government here in Houston, as well as with the United States Embassy in Jakarta, following air pollution and how it relates to health. She has asked us to help her explore and share with you pollution in Houston and Jakarta. In Houston, we have days that are too hazy or polluted to exercise outside. We have warnings on our local news stations telling us what days will be particularly bad. We were curious what times would be the best for you to exercise in Jakarta and what times you shouldn't. Statistics are a form of scientific research. Just like the scientific method that you would have in chemistry or biology class, we develop a research question before making hypotheses, testing them, and finding a conclusion. We were curious what times would be the best and worst for you to exercise in Jakarta based on airborne particulate matter concentrations. We looked you guys up, and we're pretty sure that you're almost exactly in the opposite side of the world from us here in Houston. Houston and Jakarta are over 10,000 miles apart, and it would take over 20 hours to fly between our two cities. Just because we're on the other side of the world doesn't mean that we have nothing in common. In fact, Houston and Jakarta can both have problems with air pollution. We know that a specific kind of air pollutant, called particulate matter, can be bad for your lungs and heart in Houston, and wanted to see what your particulate matter is like in Jakarta. Particulate matter can be thought of as very small dust or droplets of liquid. Particulate matter less than 2.5 microns across, or PM2.5, is especially harmful to people in the environment. 2.5 microns is really small. You could fit about 20 pieces of PM2.5 on the width of a single piece of hair. Particulate matter makes it hard to breathe and can cause heart problems. It also affects the clouds and makes it rain less.
Hello Jakarta, my name is Sathya Ramesh and I'm an undergraduate student in Dr. Ron's class. We analyzed your particulate matter data for 2016 for the two monitors shown on the map on the left. We called these monitors Jakarta Central and Jakarta South. These monitors are run by the United States Embassy. We can get your data online by using the website on the left. When we want to look at Houston's air pollution data, we have a similar website that we go to on the right. The map on the right shows our monitors in Houston. You could analyze our data. Isn't that cool? These stations take many air samples and measure the amount of PM2.5 in the air in terms of micrograms of particulate matter per cubic meter of air for each hour of the day, every day of the year. We were interested in last year's data. This is around 10,000 measurements from between January 2016 and February 2017. In addition to the hourly concentrations of PM2.5, we looked at your meteorology data and labeled the months of data as either wet or dry season based on your rain. Once we had all of the data, we thought of many different ways of analyzing the data and displaying the data to understand the data to determine what time is the best to do outdoor exercise. Each group in our class took a different approach, and that's okay. When you're asking science questions, the more ways that you can think to test the question, the better. Some of the methods we used are visual. Without doing any math at all, we could get a sense of when the highest and lowest concentrations of PM happened. Some of the methods were statistical or mathematical. Some of these calculations were very technical and complex, and some of the methods we used were both very mathematical and visual. It is sometimes easier to look at data rather than looking at a bunch of numbers. We actually have a lot of fun in a friendly competition between groups, trying to outdo each other, understanding and presenting the data message we find. We're always impressed by something or some way that other groups think of that we didn't. We did an extensive analysis to answer our question, looking at the data by month of year, hour of day of the week, and wet season or dry season. Here are just some of your results.
Hello Jakarta, my name is Nivetha and I'm a graduate student at Rice University. To start to understand your data by day and month, one of the tools we used was this neat calendar. This is a calendar that visually shows the daily concentrations of particulate matter in Jakarta over the years based on colors rather than numbers. The use of dark colors is to indicate high concentrations and light colors is to indicate low concentrations. We refer to this as a heat map. It shows the concentration of particulate matter where white is 0 micrograms per cubic meter and dark maroon is around 100. Without doing much statistics, can you see where some of the highest levels of particulate matter are? Yes, it looks like the highest months for particulate matter in Jakarta are May, June, and November. What is great about this is you can easily see the concentrations of PM2.5 day to day for an entire year. Now, what is the lowest? Yes, it looks like the lowest month for particulate matter in Jakarta is December. What I just showed was concentration, but concentration can be related to the health risk that it poses using something called the air quality index. This is showing what we thought from the previous slides, that the worst dates look like they are in May and June. Both of these calendars are useful to see where the worst pollution days occurred. If you really want to know if these months are statistically significant, that is, worse than others, you would need to take the analysis further using, for example, a test of hypothesis, which we can talk to you about offline. Statistics are very powerful tools to help us understand data. Remember, this is about 10,000 hourly measurements. It would be pretty impossible to figure out when is the best time to exercise without summarizing the data with statistics. The most common statistics used to summarize data are things like the average, or the maximum or minimum, or the median, which is the 50th percentile. But we are missing out on a lot of information if we just use one number.
Hi Jakarta, my name is Sierra Pino, and I'm also a graduate student here at Rice University. To get a quick look at what your PM 2.5 does hour to hour, we made these plots. This graph shows a randomly selected week from the Jakarta South monitor. Each blue dot is an hourly PM measurement in the week. It starts at 5 p.m. We noticed a strong cyclical pattern that repeats every day throughout the week. From this 1 week, we believe that the minimum particulate matter concentration is at around 5 p.m. and the highs are at around 5 a.m. Here's yet another graphical representation of the PM 2.5 concentrations by month and by hour. The blue and orange lines are PM 2.5 concentrations in Jakarta, where blue is Jakarta Central and orange is Jakarta South. The gray line is data from a particulate matter monitor just down the road from Rice University for the same time frame. The error bars on each line are a measure of how accurate each dot is at describing the concentration at that month or hour. Because both of these graphs are on different scales on the y-axis, we're only going to be comparing the shape of the data. What can you tell about the particulate matter concentrations in the first graph? In this case, the statistical approach came to similar conclusions to the other approaches. So if you guessed May and June have the highest concentrations of PM 2.5 in Jakarta, you're correct. Now, what can you tell about the particulate matter concentrations in the second graph? Here in Houston, we have the highest concentrations in July, though this monitor was offline for the entire months of November and December. These graphs also have different scales on the y-axis, so we will also only compare the shapes of Jakarta and Houston's PM curves, rather than their scales. What can you tell about the particulate matter concentrations in the first graph? Particulate matter is at its highest from midnight until 8 a.m. in Jakarta, and its lowest around 4 and 5 in the afternoon. Now, what can you tell about the particulate matter concentrations in the second graph? In Houston, we have our highest PM 2.5 in the morning between 5 and 8 a.m., though we never have a drastically low amount of it in the air. The highest levels of PM 2.5 overall are between midnight and 8 a.m. and lowest between 3 p.m. and 5 p.m. You can see that in the 24-hour clock that we made on the right. The months of March, May, June, and November had higher levels of PM 2.5 in 2016. So, for last year, the best time to be out was in December between 9 a.m. and 6 p.m. We can conclude that the worst hours from last year will likely remain the same, but we only analyzed 1 year of monthly data, so we can't say for sure that the same months will be the best this year. Almost every statistical analysis that any group did showed Wednesdays tend to have lower concentrations of PM 2.5, though we're not quite sure why. Maybe you know. Of course, we want to know more, like why. Why was December so much lower than November? We looked briefly at wind direction data by month and think it may be that, but we would love to look deeper. Why is the PM concentration so much higher at night? We speculate it has to do with a combination of different atmospheric conditions at night and air chemistry. There are possibly other pollutants in your air that form particulate matter at night when there is no sunlight, but are consumed differently during the day. Maybe you can pick up where we left off and let us know. So much fun, so little time. The cool thing about research in science is that you get to answer questions with your own hypotheses. We have presented the results of the hypotheses we tested, but you should always ask more questions. What would you have done differently? What different questions would you ask? Thank you for listening to us, and we'd love to talk more. If you want to connect with us or see more analysis, you can reach us through our professor by emailing her at ron@rice.edu.